Well, it is my great pleasure today to introduce Kimberly Jones. She is currently the Associate Provost for Faculty Affairs at Howard University. And before that, she was Department Head of the Civil and Environmental Engineering Department and also Associate Dean for Research in Graduate Education. So she has been moving up in the ranks towards administrative positions, but she's done excellent work on membrane processes, a lot of work on water treatment, physical chemical processes. She's got a long list of awards and honors. She actually was on the advisory board for the US EPA for a long period of time, about 6 years. She was also the chair of the Drinking Water Committee, the Science Advisory Board for the EPA as well. She served on the Water Science and Technology Board of the National Academy of Sciences. And she also served as the secretary on the board of the Association of Environmental Engineering and Science Professors. And so that's where she and I first became friends. We were both on that board at the same time. She's won numerous honors. She was a career award winner from the NSF. She has received a Top Women in Science Award from the National Technical Association, and also the Outstanding Young Civil Engineer Award from the University of Illinois, which was her master's degree alma mater. And she's also been awarded the Outstanding Leadership and Service and Outstanding Faculty Mentor Award from Howard University. So she's incredibly well-rounded, doing a lot of really interesting work. And I'm really excited about the talk that she's going to give today on environmental justice. This is something that has been top of mind for multiple years. And I think a lot of us are really excited to hear her perspective on this and think about the role that science and engineering and our field can play in ensuring equity, particularly as we think about things like the Flint water crisis and other issues that I think happen more than any of us care to think about and have realized. So with that, I'll turn it over to Kimberly. Thank you so much for coming.
Thank you so much, Paige, and thank you for inviting me to come. And as I said earlier in our little pre-game chat, I'm so disappointed not to be there in person. The plan was for me to be there in person, but it didn't work out. But it's one of those times you like, you know, it's nice that for the last couple of years, we've been practicing doing these things virtually. So I'm glad I'm at least able to come here in 2D to talk to you all today. So thank you so much for the invitation. It's great to be here. And as Paige mentioned, I will be talking about environmental justice, specifically the role of science, engineering, and policy in ensuring equity in urban water systems. And I also will say, you know, that I'll give a bit of a background and how I got here, because as Paige also mentioned, for the huge majority of my time in academia or doing research, I've really been focused on water treatment, particularly membranes, and developing membranes for water treatment. And then I, you know, was for a while looking at environmental, environmental nanotechnology and just very technical issues. But I remember at some point, you get to a point in your career when you really think about, you know, how is my work affecting, you know, kind of general society. And I happened to be rolling on to EPA Science Advisory Board around that time. And so I was really also able to really think about how important it is that policy, how important policy is to really how people see or really experience the effects of all of the research that we do. And so I started to think more deeply about the role of policy and how important that is in what we do, and also just our interactions with communities. I live in Washington, D.C. D.C. is a very urban area, quickly gentrifying. And so some of the inequities that have cropped up as a result of a lot of different factors have come to my attention also. And to go way, way back, the reason I am an environmental engineer really is because my sophomore year in college, I had an internship, and I wanted to be a structural engineer. My dream was to build bridges. I used to want to be an architect and then a civil engineer. I wanted to design bridges. I thought it was just really I could see myself just doing that for the rest of my life at that time. And I happened to have an internship, and I talked to an engineer, and he mentioned environmental racism, which was the term they used then. And I had never heard of it. We got into this conversation, and I decided then I wanted to be an environmental engineer because I wanted to have the science and technology and the technical background to be able to try to make a difference. And then I went on to finish my degree in a graduate school and got into water treatment. And so now I kind of consider this full circle where, much later in my career, I've begun to really focus a little bit more on environmental justice. So that was a long introduction, but I wanted to just explain how I came to really start to think about these things. So first, will state something that you all probably already know, and that's that we have a global water crisis. This is a crisis that has been known for a number of years, continues to be a challenge. The National Academy of Engineers mentioned in their 2008 report that this was a global challenge, and we're still dealing with it. These statistics are relatively well known, but child dies from a water-related disease every 2 minutes. 1 million people die due to water, sanitation, and hygiene-related illnesses annually. There are 844 million people live without access to safe water, 2.3 billion without access to proper sanitation, and we lose about $18.5 billion in revenue from avoidable deaths due to lack of access to basic water and sanitation. But what we may not know, and this may sound provocative, but it's true, and it's that we have a water crisis right here in the United States. We have about between 9 and 45 million Americans who receive water from a source that violates the Safe Drinking Water Act in about a 30-year span. 63 million Americans were exposed to potentially unsafe water more than once in the last decade. We have about 3 to 10% of our water systems in violation of Safe Drinking Water Act annually. And we will need to invest about $384 billion in our water utilities to be able to reliably meet water regulations. And so we should be aware of these issues and just know that right here, even though we have a very robust framework for providing safe drinking water, many of our communities do not experience that same safe drinking water. And the burden affects Americans in a very disproportionate way. So, you think, okay, water is treated in a centralized water treatment plant. It goes through the distribution system and it hits different communities in much the same way. But when you look all across the United States, that actually is not the case. And we have seen water justice challenges all across the continental United States. For example, in the Southwest, we've seen issues with nitrates and arsenic that disproportionately affect Hispanic households. In the South Central part of the United States, we've had issues with nitrates and many, many unpiped communities in some parts of Texas, and particularly with communities of color. In the southeastern part of the United States, we've seen issues with PFAS and coal ash. In some areas, particularly in North Carolina, it's been an issue disproportionately affecting communities, lower income communities. In the Midwest, large percentage of unpiped communities and also issues with lead, as Paige mentioned, and in Flint, that was an issue that came to national attention. In northeastern part of the United States, we've had issues with around lead in Newark, New Jersey, for example, coal ash in West Virginia, PFAS issues in parts of New York. And again, these are burdens that are disproportionately felt in communities of color. We also have in north central part of the United States issues with PFAS and mining waste around some of our indigenous communities and also communities of color. And lastly, in the northwestern part of the United States, we have had issues with arsenic and bacteria in some of our communities. So again, this is not an exhaustive list of all challenges, but these are just some issues, some examples of issues that have hit communities in disproportionate ways. But when you think about what I mentioned in my introductory remarks, EPA water quality regulations are really very intentionally designed to protect public health and the environment. We have the Clean Water Act and the Safe Drinking Water Act. So these two together should really make our water safe, safe to drink. We have our primary drinking water regulations. They apply to all public water systems. There are about 151 public water systems in the United States. They provide water to 250 million people, and that includes schools and parks, and all these places are protected by our drinking water regulations. When you dig deeper in the Safe Drinking Water Act, you see that it includes science, it includes public engagement. In my time on EPA, I got to sit at the table as some of these were drafted, and we know that it is a very, and I can say from experience, is a very robust process. There's scientific underpinnings in all of our regulatory determinations for our contaminants. They go under re-review every 6 years or so. We have over 90 contaminants regulated by the environmental regulation, by the EPA, but yet many water systems cannot comply. This graph shows the number of violations of drinking water regulations over about a 30-year period. And we can see here, I want you to focus on the top blue line. That's the total number of violations, and then under it, it just breaks it out by type of regulation that was violated. But even if you focus on the top blue line, you can see here that you kind of get these increases right around the time that new drinking water regulations are promulgated. And so that means, and when you look at where those violations occur, many times they occur in communities, in rural communities or smaller communities, where they may not be able to update their drinking water plant in enough time to meet the new regulation, even though you have a bit of a heads up and some time to prepare to meet the regulation, these communities still are unable to do so. And I don't have it here, but we also are seeing that the amount of time that the community remains in violation is also longer in certain communities, particularly some of our smaller communities. The bar graph on your right shows, if you look at the different types of violations, you can see how many violations we have, and it also varies with the specific type of regulation that was promulgated. Then when you look at the same thing, the number of violations per water system over the same 30-year period, we see that when you break it down in a type of community, you can see that rural low-income communities are much more likely to have violations than rural high-income communities, and then suburban communities, and lastly, urban communities. And so our smaller systems are much more likely to rack up these violations. And this is another issue that I was always very focused on regulations, but there are other kinds of water insecurities that people experience. One of them is not having pipe water. There are a large number of Americans that don't have access to pipe water. This hex map depicts a spatial distribution of households without pipe water access. The lighter colors indicate areas where there are a higher number of unplumbed households. And you can see here that as the color goes from dark blue up to yellow, there's an increase in that indicates an increasing number of households without pipe water access. And so when we look at how these numbers are, how these colors are distributed across the country, you can see here that urban, and when we overlay that with demographics from the Census Bureau, we can see that urban households headed by people of color are almost 35% more likely to lack access to pipe water compared to white non-Hispanic households. And also lower income households are more susceptible to a lack of pipe water access, and that's regardless of differences in housing characteristics, race, and regional wealth. Here's another map, different study, but broken down by violations. So here we have a map that overlays drinking water violations. And on the left, you have all violations. On the right, specifically health-based violations. So these are violations that result in in health, like coliform rule or other rules that will lead to a public health action, a negative public health action. And then you overlay that with demographics, where if you have a lighter color, as you go from this white color to blue, you have increasing populations of color. And as you go from a light color to orange, there's an increasing number of drinking water violations. And so when you look at this map again, you can see that there are relationships in between multiple socio-demographic characteristics such as race and drinking water violations across the country. And so we begin to get a picture that we have an issue. And when you look at this map, just the dark blue are the issues with the parts of our country where the largest number of public health violations. So all that is a backdrop to this whole issue of environmental justice. So when you think about what exactly is environmental justice, on this slide, I am using the definition that has been adopted by the federal government. And that said, the environmental justice is a fair treatment and meaningful involvement of all people with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies. So environmental justice movement really started back. This picture on the top right shows a neighborhood back in 1982 in Warren County, North Carolina, where a hazardous waste landfill was planned to be built in their neighborhood. And the community found out about it. They came out en masse to protest. They protested for 6 weeks. It got nationwide attention, because they didn't want this PCB landfill in their community. Unfortunately, they lost the battle. The waste site was placed in their community. However, it got national media attention. It really, began to paint a picture of this whole idea about environmental justice. And it was the legal challenges that they were able to mount against Warren County to fight the landfill was really considered to be the first major milestone in the environmental justice movement. And then this picture at the bottom, that shows a more recent issue from 2014, where a company in North Carolina spilled almost 40,000 tons of coal ash into the Dan River in North Carolina, which was an emergency situation. We got concerns about the environmental and economic impacts for communities downstream of that site. And this picture, again, was taken by a community group called Appalachian Voices. And so you think these issues are not uncommon. On the left here, I have another picture of that dumping. So you can see here, this gray area is the coal ash. The gray area is where the coal ash was dumped, and this brown area is kind of what the river would look like normally. And this right after the community began to make folks aware of this issue, the company responded. They have landfills now, and they've addressed the issue, so they no longer have this coal ash being dumped into the river. But this is not the only issue. It's not the only location it's happening. In fact, there are about 1.5 million people of color who live in catchment areas of coal ash surface impoundments at 277 power plants throughout the country. So this is a much broader issue. So when we look at one particular site, you sometimes lose focus that, these types of things happen to many people in other communities as well. I also want to highlight another issue that many of us have heard about, and that's Flint. I won't get into a lot of detail because I think most of us probably have heard the issues around the water in Flint got national attention, but I really want to focus on the aftermath, because when an environmental injustice occurs, particularly around water, which is an issue near and dear to my heart, it causes effects that aren't rectified by kind of the solution to the problem. So even after you correct the problem, there are longer term effects. So this slide shows at your top left, that was because of a settlement, a fallout from the issue in Flint. They work with the city worked with data scientists to create an online interactive map of that shows the status of lead pipes in homes in the city of Flint. And so residents of Flint can now log on and they can see in real time the status of the lead pipe replacement. And so they can go and see in their neighborhood and their homes where, what progress has been made, so it can allegedly be more confident that the pipes that the water that they're drinking is safe. The middle picture shows workers actually working to replace those lead pipes. But yet on the right, we see a picture which is relatively recent because they have a mask. It's a picture taken in the last couple of years. Residents are still distributing bottled water. There's still a good amount of distrust in and around Flint. And so they still have not transitioned, in some of the residents have not transitioned to using tap water because there's still that lingering lack of trust. And so once, my point here is just to say that these issues take a very long time. There's a lot of deep work that has to be done to regain the trust after that trust has been broken. So you might think, what is the federal government doing? The federal government really is ultimately responsible for protecting the public health and around environmental issues. And in 1994, President Clinton signed an executive order around environmental justice. We have it here: federal actions to address environmental justice in minority populations and low-income populations. And they developed an interagency working group on environmental justice. And so now federal agencies work together to try to include environmental justice in their work. In 2020, the Office of Environmental Justice put out kind of a roadmap to amplify some of their goals. And I put 3 of the goals here: deepen environmental justice practice within EPA programs. They want to work more closely with partners to expand a positive impact within overburdened communities, and demonstrate progress on significant national environmental justice challenges. And those challenges I put here, they're lead disparities, drinking water, air quality, and hazardous waste sites. And so there are efforts, there are many efforts within the federal government to right those historic wrongs, but it is not easy. Environmental justice is very complex. When you think about indicators, the left side of the slide shows what some environmental indicators are. And these are environmental indicators identified by the federal government, by EPA, as important indicators of adverse health effects based on environmental contaminants. And then on the right, there are specific demographic indicators. And these are indicators that may indicate a vulnerable community. So those may be race, education, income, primary language spoken at home, and age. And so when you overlay those 2 things, which are the environmental indicator and the demographic indicator, you can come up with, they have here a EJ screen, which is really a tool where you can overlay those to come up with an environmental justice index, which really is just a screening tool to tell you, okay, this is a geographic area where this community may be vulnerable or may be in danger of being burdened disproportionately by some kind of environmental contamination. And so at this point, hopefully many of you are thinking, what can we do? How can we contribute to these solutions? And this is something I've been thinking about a lot recently, just because, again, most of us listening today are probably researchers. You think about your research, you have research that may intersect with environmental issues, and you work hard to kind of think about solutions, to understand more about the science behind this, and to understand how we can use science to really solve some of these problems. And I would say to maybe extend that and think about how your science and how the science that you do intersects with policy, and how will it be used and is it being used to impact the work of decision makers and policymakers as they really think about how to script regulations and what regulations are most appropriate and what the science is behind those policy decisions. But also we all have to work with stakeholders. We cannot do this in a bubble or in a vacuum. We need to engage with partners. We need to engage with communities and other stakeholders, grassroots organizations, water utilities, advocacy groups. We all have to work together to come up with robust solutions that actually will be helpful to all communities, not just some communities, but all communities. And that's something we really have to be intentional about. And when we think about these, I would consider that these would be considered to be next generation solutions, right? They're solutions that are not incremental improvements. Now I'm going to pick, and I've been doing this all along, but pick more on the water industry, because in the water sector, we do tend to kind of respond to policy decisions and those regulations I talked about earlier. When there's a new regulation, we get really busy to make sure we have a solution that meets that need. But I do think we need to be a little bit more forward thinking and kind of think about how can we look further down the line? How can we get ahead of the game when we're thinking about what's coming as climate change brings more uncertainty to our solutions? We do have to be a lot more forward thinking in how we develop sustainable solutions. And I think these kinds of sustainable solutions will need to include those partnerships between universities, other industries, and government agencies. And also I have here some key targets for improvement. And this is just what I think we need to be thinking about as we come up with our innovations, multi-barrier approaches. How can we look at different types of different classes of contaminants? How will we push water reuse and bring solutions for water reuse faster, looking at multi-contaminant removal, decentralized treatment. And when we think about decentralized treatment, thinking about developing decentralized treatment on a community level and including members of the community as you develop those treatment processes. And then of course, always we want to reduce the energy cost to be more sustainable. I'll skip this because I'm looking at my time and I do want to, this is a talk, I like to leave a lot of room for discussion at the end, but this is where I do want to kind of push the point that we have been in the last 20 years, really when we think about drinking water innovation and huge innovations in drinking water, over the last 20 years, what we've been doing is really talking about what the challenges are. We need to really think about solutions. And I think the barrier here is that we haven't brought in other partners to the table to really think about what those solutions might be and what sustainable solutions may be. This is just also to drive home the point about partnering and coming up with robust partnerships. We're doing some of that at Howard University, where we have a partnership with the local wastewater treatment plant, a couple wastewater treatment plants on the East Coast, one in DC and one in Hampton Roads, where my PhD student, Raheel, was really working to come up with a very applied, implementable solution to some issues we've been having with our drinking water plant or with our drinking water treatment. And it's really a very, what I believe is a very forward-thinking project. And I think it's interesting to the student, it's good for the wastewater treatment plant also because it is really a strong partnership where we come up with solutions together so we can be confident that our good science that we're doing in a lab will be implementable. The federal government is also working on those kinds of partnerships. EPA has an initiative called Urban Waters, and Urban Waters is a partnership between a couple of entities. One is the Groundwork USA, which is it's based in New York, but it's a national program, and it's work to work on community-based partnerships to empower people, businesses, and other organizations around environmental well-being. And also the River Network, which empowers and unites, again, communities around rivers and other water bodies to increase access to affordable clean water, healthy rivers, and they work specifically and intentionally with communities. So if you're interested in working with communities or community-based partnerships, EPA is providing more guidance for you to be able to kind of plug into these existing networks. I also want to highlight something that I'm involved in. which is I'm a commissioner in DC and an interstate commission on the Potomac River Basin. And this is just a picture of our installation a few years ago, pre-COVID, where we met with the mayor, and these are the other folks on my commission. But we are part of a broader commission made up of folks from the surrounding states, Maryland, Virginia, West Virginia, Pennsylvania, and where we work together to come up with solutions to protect the Potomac River watershed, because that impacts all of the states. And so I think this is I highlight this because I think it's a very nice partnership where we come together quarterly to really talk about water quality, water quantity. I chair we call it JEDI, the Justice, Equity, Diversity, and Inclusion Committee, where we are now trying to make sure our work really brings others to the table, particularly members of vulnerable communities who may not necessarily or traditionally been a part of the conversation. So we're really trying to be forward thinking in that way. So that is my last slide. I really want to thank you for inviting me today. I hope we can have a robust discussion in our remaining time today. So thank you so much. I will stop sharing my slides.
Hey, Kim, can I ask a question?
Absolutely.
Thanks for your talk. It was really thought-provoking. I enjoyed it. The one thought, or I mean, some issues that maybe are close to home in DC that I was wondering if maybe you could speak to. I mean, obviously DC had its own lead issue that obviously Mark Edwards helped to bring to the fore. And then there's also the issue that I read years ago about contrasting the Anacostia with the Potomac, and how the Anacostia flows through mostly underprivileged minority areas and has not really been focus of, cleanup efforts, but the Potomac flowing through more, the downtown DC area and more affluent areas is focused more on cleaning it up and making sure it's safe and looks good and all this. So anyway, I don't know if you could comment on any of those local
Yes.
DC issues and what's being done or
Absolutely.
how.
Yes, thank you for bringing both of those up. The lead issue, I think, was around 2003, 2004 timeframe, where DC did have its own lead issues. We're continuing to have, it didn't get as much attention as Flint, but it did. The fallout was that there were a lot of communities that lost trust in the water. We now have a lead replacement. We continue to have a lead replacement program where the DC Water is working with communities and with households to try to encourage folks to participate in their lead pipe replacement program. And so we are still living with the kind of, and it's, almost 20 years later, and we're still trying to, in many cities, the infrastructure is very old and it's expensive and disruptive to try to replace pipes. And when I was on the advisory board at EPA and on the drinking water committee, I also served as the liaison to the National Drinking Water, I'm getting it wrong, Utilities Council. And it was made up of water utilities. And we had these conversations about lead pipe replacement. And that's where you get the kind of rubber hits the road, because we want to replace, and I don't think there was anyone at the table who said we don't want to replace the lead pipes. The problem is it's expensive, it's disruptive, and you have to think about how it's done. Really, it's the implementation of that process that really is tricky, but it's the implementation of the pipe replacement is also the thing that can exacerbate these inequities, because when you think about it, you have to educate homeowners. The city is responsible for replacing the pipe up to the homeowners, up to the property line. And then the homeowner needs to agree to do the rest. And you don't want to do partial lead replacement, that's worse. So you're now in a situation where you have to kind of get out the word to try to encourage homeowners to agree to it. And you have to reduce the cost so that it's not cost prohibitive. And so those are kind of some of the things that DC is busy doing to try to increase the rate of the lead pipe replacement activities. Also, to speak to your issue about the Potomac River versus the Anacostia River, that also, there's been a lot of work a lot of work there over the last few years. Anacostia now has a lot of groups. There's Anacostia Water, there's Waterkeeper. There are a number of kind of grassroots organizations that have been busy trying to continue to bring, to publicize the status of the Anacostia River. But there's been a ton of work done to try to clean the Anacostia River. So there are legacy pollutants that are still there, but it is much improved from where it was years ago. And interestingly, at the same time, DC has gentrified to the point where a lot of the communities now that abut the Anacostia River are no longer in the same socioeconomic, so it's ironic that right around the time the Anacostia River is being cleaned up and there's greater attention and there's some, tangible results, the communities around there have really changed. The demographics have changed. The demographics in DC have changed tremendously over the last 20 years or so. And so with that, they've, been able to put more money into improving the Anacostia River, but also, as I said, the demographics are different. So it's a very interesting thing to watch. What I am, kind of interested in lately in DC is really, looking at, we've been also doing a lot more with green infrastructure, trying to take our gray infrastructure to green and trying to, improve things in that way, trying to manage our stormwater better. And when you see a lot of that work, that's really when you have to also try to think about how communities are being impacted. How are decisions made about where to put these green infrastructure installations? Are we doing it equitably across the city? Is it hitting all, neighborhoods at the same rate? Those are questions that I think we have to continue to be aware of, because a lot of times you see these nice green infrastructure installations, but it's not always in, it's not happening at the same rate across DC. And so there's still inequities, but I do think we've made progress at the same time.
I'll go ahead and call on Bill. He's got his hand up.
All right, Bill.
My question was just if you had any good life lessons or lessons learned or pitfalls in community engagement, what worked, what doesn't, challenges and successes. So
absolutely. I think I've witnessed challenges and I've also seen some success, but I will say just generally, I think in our environmental community, one thing I see a lot, and this is in, reviewing for panels at NSF or other places, members of our community, I do think we're beginning to understand that we need to work with communities when we kind of do some of the work we do. And I've seen examples where it's done really well, and also examples where it's not done well. And I think some things to be aware of when you want to engage in a community, you need to make sure that it's done in a way that's respectable, understands that there are benefits. A lot of people think, okay, let me go out to this community, let me help them, or let me educate them on these issues. Let's help them with these issues. Let's provide a solution to the community. And all of those types of, all that language and those efforts, it only goes in one direction, right? It's unidirectional. That is always a mistake. So if you are thinking about working with a community, you really need to think about, you read over your plan and make sure it's really community engagement. It's not, you're not doing research to a community or doing research for a community. If you really want to do research with a community, you have to bring the community, you have to learn about the community first. You need to kind of embed yourself or someone in that community to really understand the community, just kind of what that community is like, whatever it is or whoever that community may be, and understand the power dynamics within a community, understand, what's going on in that community. So it doesn't seem like you are entering that community trying to kind of usurp whatever they had going on, because many times they have their own kind of structure within the community. You need to understand that to be able to work within that structure and not to come impose a new structure on the community or, impose yourself as the top of the hierarchy in a community. So I do think that's something that, we need to be aware of, as we go try to work with communities, particularly around environmental issues, because I do believe it is very possible to do more harm to a community by going out and doing it wrong. And so I do think it's so important to, and what we don't often understand as researchers, if we go out in a community, in a specific community, and we mess things up, that community may not be thinking, okay, Kim Jones came in this community and did a terrible job. They're thinking some researchers came in this community and did a terrible job. So then when Paige goes back 3 years later with a really well thought out plan and wants to work with the community, they're going to say, no, because remember, you came before, and it's no way she can even put a picture of us up. They won't care. They will say, we're done working with you researchers. We're done working with you university folks or whoever you are. They won't want to do it. And so we can easily do more harm than good by doing it wrong. And so I do think we need to be mindful of how to do it right.
Thanks, Kim.
Mm-hmm. A Paige.
I've got a question to kind of follow up on Bill's question. There are a lot of people on the Zoom that are students or young researchers. And so this kind of work takes a lot of time. It takes so much time to build this trust and to build these relationships. And when you're thinking about the way academia is structured, you get 3 years of a certain amount of money, and you need to be showing. I just got off a meeting this morning, every 3 months, you have to be showing them the results and the improvement and the progress. And as a young researcher, you've got this ticking clock in your head that you have to meet tenure deadlines and things like that. And so what advice do you have? Because a lot of people do want to work with communities and help. And do you have any advice for younger people in particular, or for older people that can help change things?
Yeah, I do have a lot of thoughts about this. I think, and also I will, all of these thoughts aren't my own. I'm on an advisory committee an NSF advisory committee on environmental research and education. And that's something we've been talking a lot. I'm also on an advisory committee for engineering. And so both engineering, the advisory committee is directly to the engineering directorate, but the environmental research and education advisory committee cuts across NSF. So so that's SBE, that's CBE, that's, all across NSF. And so we've been having conversations directly about the issue you brought up. Really, how can we get early career researchers to engage in the environmental community, to really partner with communities in a way that's productive, in a way that they can continue to move forward in their research career, because with the understanding that these kind of partnerships take time. And if it's so hard that, it won't happen, then our researchers may decide not to do it, or they'll do it wrong, or they'll take shortcuts or whatever. And so I do think that planning grants are one way that NSF has said, maybe, I'm beginning to see planning grants a lot more often with a lot of the NSF, especially the larger initiatives. It used to be just, for the ERCs, but now I'm beginning to see planning grants for a lot of their other solicitations. There's also, you probably heard the new directorate, TIP, Technology, Innovation, and Partnership, that also cuts across NSF. So TIP will kind of be a directorate specifically to help with these kind of partnerships, and take the fundamental research that is the backbone of NSF and take it to implementation, and take it to the application stage. And so the TIP directorate is specifically focused on this. So I do think our early career researchers have more guidance than I feel like our generation had in how to do this, and more resources, because I do think NSF and other funding agencies are understanding that kind of work is not just, it's not trivial work. It's really important work, and it's work that takes time and needs to be done right. Our committee, actually, and I'll email it, just finalized a report on engaged research. And they address a lot of those issues. So once it's gone through all the editing and all that, I will send it out to make sure you all see it early. But it is specifically on how to do, and we do plan to go through NSF, to do our road show, to talk to the folks at NSF about engaged research, so that they, so that researchers understand, how important it is. We do kind of touch on best practices and those kinds of things, but also to figure out how to get the word out to the research community also, so they can benefit from that information.
That's great. Yeah, I think a lot of people might be interested in that. And if you wanted to send it to me, then I could, anyone who's on that wants that, feel
Okay.
free to send me an email and I can forward it when Kim sends it. Thank you.
All right, thanks. Erin?
Yeah, hi. Thanks for the talk. I'm wondering what the role of undergraduate education is, and how, if you have any kind of tips for how to prepare our undergraduates for kind of making sure that we're doing this right too.
Yeah, that's another issue we have begun to talk about a lot, because I do believe if you wait till graduate school, you're going to miss, well, every undergraduate who works as an environmental engineer doesn't go to graduate school. So we can't say, okay, let's hit that. We don't have time. Undergraduate, too busy hitting all those ABET requirements. We got to get them out and they'll deal with it in grad school. We have to start to, I think a key for undergraduates is there's a couple things. One, to have them understand this whole idea of systems thinking, which I don't know if we always do as engineers or environmental scientists and engineers, but I think in our field, we need to start to just, as early as possible, have our future engineers and scientists understand that we have to understand how whatever we do impacts others. We think about it from a safety, we think about codes and, so I do think our engineers understand when they're doing design, they have to understand that, the appropriate codes that they have to, but, and design engineers in the water sector are thinking about regulations, but I think as importantly, we need to start to impart an understanding of how our work impacts the community. And I think NSF is beginning to do it with their focus on societal impacts and, kind of thinking about societal impacts and encouraging the engineering and science community to work with social scientists and to work with others. It's also important to say, we can't all be an expert in everything. So we need to understand and respect the role of our collaborators and folks from other disciplines who know how to do this and can help us to do it right. And so as undergraduates, I don't think it's too early to have them start to understand, how integrated their work needs to be with others. And I think that should continue through undergraduate. And I think if we started as earlier, it will go through their thinking in graduate school. If they go and teach, then we'll finally get to a point where we have instructors in a classroom who have this mindset, who are teaching our undergraduates. So I do think it's a cycle that needs to start at the undergraduate level. All right, thank you. Aboya.
Hi, Kim. Thank you for the really thought-provoking talk, and allow me to think a lot of ideas for my water and wastewater treatment classes with a graduate level class that can incorporate those materials in. But my question is around, I think really in the line with Paige's question of how early career researcher like me can engage. I think my question is about kind of two levels. The first level is like what you're saying, that I think build the relationship with the community takes a lot, not just takes time, also takes a lot of skills of navigating those relationships. I wonder, do you know, maybe this is a question for Paige or Bill as well, is at university level, their offices are helping that, help researchers and professors to engage with communities. So like when we are, I know we have offices to build correlation with industry, that they do a really nice introduction. Here, you're gonna meet with these folks. This is what you need to be careful of. This is how you should prepare yourself. So like really clear guidance of that. I wonder if there's something similar at a university level or college level. My second question is a bigger scale. You talked about partnership a lot of different researchers, government, and stakeholders. I want, and then I wonder if there is any of these different parts in the partnership will need to play a leadership role to take this further ahead. And if so, who would that be? Is it more likely the government, like NSF or EPA would take those start those initiatives, and then that other parts will start engage, or you envision something similarly, the government will take initiative that more at local scale, or other possibilities.
So thank you. I see in the chat, I think Paige and Bill have dropped some links in there in Minnesota that probably will be helpful. And I can also say at our university, what we have been at Howard, what we've been trying to do is to right now, I will say it's we have a distributed group of folks who work in the community. In my opinion, is too loose of a group. So what we've been doing lately is really, I think Minnesota's a little ahead of us, is to develop an office where researchers can go to kind of understand, to get best practices, to get some historical kind of institutional memory on what partnerships have existed and, who the contacts are, just to understand, because it does take time to say, hey, I want to engage with, or this is what my research is. One, who is the best partner? Who is a good partner? Who are the folks I would talk to? How do I get to them? All that takes time and energy and effort. And I do think having a centralized office, whether that's at the university level, the college level, the department level, but having guidance for researchers, I think along those lines is really important. So I do think it needs to happen at some level. It should not be on the shoulders of the individual researcher to go out and do all this work. And so there also needs to be a repository and some kind of a responsibility on the researchers who've done it and done it well to report back to these offices so that they can help the next person who wants to come. And your second question about if the funding agencies and was your question about who should be responsible or what are they doing?
Just in general, if we want to incorporate more community engagement that will ultimately lead into a solution, who do you think would be the leadership in the partnership? Or if there is, or do you think there needs to be a leadership?
That's a very important question because we've talked a lot about co-production, right? So when you do these, it's really co-produced. It's not, okay, the lead researcher is leading it, or research group is leading it, the community's coming along, but we're really trying to get people to think about this as a partnership where, it needs to be set up as much as possible so that there's not an overwhelming power imbalance where, it's set up so the researchers kind of coming up with an idea, and this is not easy. I'm not trying to say this is easy because we're used to coming up, if we have to write a research proposal, then it's going to have a plan. So then we say, okay, we have this plan for community engagement. We got to go implement it, which means already you're going out to implement a plan you've developed. And so what we're trying to get people to do is to go before that when you're developing the plan and, make those connections then so that the community's involved on the front end when things are being developed. Funding agencies, I heard conversations about considering who you grant funding to. So maybe in some cases, it may make sense to actually fund the community partner directly rather than have the funding go through the university, but to think about ways to fund the partner. And so the partner really is leading a portion and then the researcher is leading a portion together, they're leading the whole thing. And so though I think there are a lot of different frameworks that could work, but I do think we'll begin to see a lot more, at least with NSF, a lot more intentional, a lot more development around how they do that, because I know there are conversations. I haven't seen the outcome yet, but I do think they're on the right track for developing those kinds of resources.
Hi, I'm a second year PhD student in Boyle's lab, and I have a question kind of jumping off of hers. I'm wondering what skills you would recommend that we as early career scientists would really work on developing in your experience to have the best communication with policymakers and then also with community members.
I would say that's a great question, Phoebe. I would say communication skills. I don't think we are always the best in communicating what we do to a non-scientific audience, right? And so we try, sometimes it does not, it really fails royally if we're not aware of the audience we're talking to. I know, I'm always probably overly concerned whenever I'm giving a talk. Like that's how I went on your website for Warren lecture, try to figure out who am I talking to? Is this, because you want to make sure whatever you say is appropriate for the audience. And so I do think having the ability to talk about what you do, or what you want to do, or what you need from the community or whatever, in a way that that they can understand and engage with, but that doesn't mean talking down. A lot of people, and I hate when people use the word, how can we dumb this down for? It's not dumbing it down. It's really learning how to talk to different audiences. That's all it is, and so being able to have that, it's kind of a code switching, to be able to code switch appropriately, I think is a really important skill. And it's not, we actually, in most PhD programs, I think I actually learned the opposite. I remember struggling I used to like to write as a hobby before graduate school, but just write, prose or poetry or whatever. And I remember having to learn to write to write for a technical audience, because it's a different skill. And I think similarly, learning that skill and how we communicate, we have to be, we have to do that code switch and learn how to talk. If you're at a conference, everyone is in your field, there's a way to communicate to that audience. If you're in a meeting with your community partner and you want to talk about the research and get their thoughts, there's a different way you're going to communicate that. And so I just think having that skill is important. Also, just being able to talk to being able to get valuable information from different partners is also, I think, a skill, because a lot of times, you're speaking two languages, not just what I was talking about before the code switch, but just different disciplines have different languages, so learning how to sort that out. If you're talking to social scientists about a way you can collaborate, really understanding each other's language and being able to do that, or even recognize in the beginning that you have to do that. So I think the overall skill I would define is, how to work on an interdisciplinary team. And I think a discipline, I would include those community partners as kind of part of that group, but how to communicate within different groups to get to receive information, as well as to provide them with information.
Thank you.
You're welcome.
I think we're butting up against the end of time here. Kim, thanks so much. This was really a great talk, and there's a lot of great conversation afterwards. I think hopefully we'll keep having these conversations, but I really appreciate you coming here and starting us off here. So everyone, please join me in thanking Kim.
Thank you so much for having